Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. D-glyceraldehyde is the reference compound for the DL nomenclature system. In a Fischer projection, D-glyceraldehyde has the ChO group at the top, the CH2OH group at the bottom, and the OH group on the right side at the chiral center, C2. The D designation specifically means the hydroxyl group at the reference carbon points to the right in the Fischer projection. Moving on to the next step. Identify the standard Fischer projection of D-glyceraldehyde. By definition, ML Fischer's convention, D-glyceraldehyde has ChO at top, OH on the right at C2, H on the left at C2 and CH2OH at the bottom. Moving on to the next step. ChO at top, H on left, OH on right, CH2OH at bottom. This matches exactly the standard definition of D-glyceraldehyde in Fischer projection. And for the final step. H at top, O on left, ChO on right, CH2OH at bottom. This is a rotated redrawn representation. If we redraw this Fischer projection by rotating 180 degrees in the plane, the ChO comes to the top, and we need to check the configuration. However, rotating a Fischer projection 180 degrees in the plane preserves configuration, ChO goes to bottom, CH2OH to top, that gives a different arrangement. Actually, option B represents the same chiral center, the horizontal groups, O on left, ChO on right at C1 level is not C2. Re-examining, in option B, if we consider this as the C2 chiral center with H on top, O on left, ChO on right, CH2OH on bottom, rotating the Fischer projection by 180 degrees gives ChO on top, CH2OH on bottom, H on right, O on left, that would be L-glyceraldehyde. But actually, option B can be seen as an equivalent representation by rotating the molecule 180 degrees, top becomes ChO, was CH2OH. Wait. Let me reconsider. Rotating a Fischer projection 180 degrees in the plane is allowed and gives the same compound. Option B has H at top and CH2OH at bottom. Rotating 180 degrees gives CH2OH at top, O on right. This is getting complex. The key insight is that all three drawn structures, A, B, and C, are equivalent representations of the same molecule, D-glyceraldehyde, just drawn from different perspectives or with the carbon chain oriented differently or rotated. CH2OH at top, O on left, H on right, ChO at bottom. This is the Fischer projection with the carbon chain inverted, CH2OH on top, ChO on bottom. In a Fischer projection, rotating 180 degrees in the plane is a valid operation preserving configuration. Rotating option A 180 degrees gives CH2OH at top, O on left, was O on right, now on left after 180 degree rotation, H on right, ChO at bottom. This matches option C. So option C is the same compound as option A, i.e. D-glyceraldehyde. Similarly, option B can be shown to represent the same stereochemistry through allowed Fischer projection manipulations, rotating the entire projection, redrawing with the aldehyde carbon on either end while tracking stereochemistry. Since options A, B, and C are all valid representations of D-glyceraldehyde, the answer is D, all of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.